All right, let's get started then. Hey everyone, for those on Zoom, hello. So yeah, we have Ian in person today. Thanks for coming. Ian is a 2019 HBS grad, Section G. Woo! There we go. Section G in the house. Yeah, he'll be telling us about something really foundational. We thought it would be good to have a session, an educational, technical session about the most important, like the data layer, under which kind of everything is built in terms of the models. And Ian has a really great background from that he'll talk more about from various companies in the Boston area and yeah, working in the analytics space. So one more housekeeping item. Today's a big day for AI Club. We have the holiday party starting at 8 p.m. In Hamilton. Yes. Hamilton Lounge. So please come join us at 8 p.m. There will be food. So
no food, catered. Yeah. So join.
Great. I'll hand it off to Ian then. Thanks.
Hey everyone, good to meet you all. Because I went here, I know that your name tags are not your actual names, which is like a little deceptive. Awesome, good to meet everyone. I don't know if anyone's seen this meme on Twitter, but we have show me an image of a great data AI club presentation at business school. Like make it clear that it's at a business school, and you can see, it has some pretty interesting text up there. And then finally, making the slides about the history of databases, but also making sure that the content is interesting and the audience is enthralled. So this is kind of, what today's going to look like. So you can see here, GPT-4 still can't spell text. And I don't know, I kind of feel like we'll look back at a time period and be like, remember when you could generate images, but they couldn't do hands and text, right? Like that will be, an interesting one-year period. Awesome. So today I'll do a little bit about me. I'm going to talk a little bit about database history, which I think is going to be kind of boring, but I think it helps explain kind of like what's changed a lot in the last 10 years, and sort of also describes a little bit about if you're a data professional, if you have data professionals, if you're working with them, sort of what they were capable of 10 years ago, what they're going to be capable of 10 years from now. Talk a little bit about some of the data stuff I've worked on. Talk a little bit about large language models. I can certainly go more into that stuff. And then maybe some like unsolicited advice to end with. And these slides are kind of a combination of tailor-made and then just like pulled from other presentations, including ramp, new hire onboarding. So definitely like pause me at any point if there's anything you want to talk more about. I doubt it'll take more than 20 minutes. Cool. Awesome. So Wayfair, 2013, 2017, before business school, sort of self-taught a lot of data science, one full tech stack ago. So Wayfair, when I was there, had servers in Waltham, and there were individuals I knew who would occasionally like drive to Waltham and plug them in, which is sort of funny because I think like if I had joined a different startup or if I'd started working like 2 years later, I would not be able to say that. And like no one I work with on my team has ever worked on an actual like physical server. It's all just like in the cloud. So I got the absolute tail end of that. Worked on a lot of pricing recommendations, came to HBS, was in Section G, was at Zillow that summer. I was at Drizzly for sort of 3 phases, I guess maybe 4, which was like 9 months after business school. It was kind of like a startup, 120 people, all in Boston, not growing as fast as our investors wanted. And COVID happened, and it was like Peloton, Zoom, Drizzly. It's like a massive COVID stock. We sold to Uber at the exact right time. It's been all downhill for that company ever since. We had a data breach. We had an FTC investigation. So that was the start of like Lena Khan's FTC, where anything antitrust got litigated. So I got to go through some of that, which is pretty cool. Ultimately, did not want to be a part of Uber Eats North America, Uber Eats North America New Verticals, alcohol, which is sort of like where they slotted Drizzly in. And then went to Ramp after that. I think like, they're a really fast growing FinTech company. I know a lot more about like SVB than I ever thought I would. That was probably like the most stressful time period I've had, which was a lot of fun. Awesome. And then, I wouldn't say this to a non-HBS room, but actually got pulled into ramp from my bunkmate on Yacht Week, which is just like, just a horrible, story of like why business school matters. But a more fun one is this is me at orientation, and actually sat next to my future wife at orientation, which is kind of funny and random too. Also section G. Yeah, woo! Awesome. So database history. And so we're going to talk about like what I'd call production SQL databases. OLTP stands for online transactional processing. That's kind of like the canonical stuff. That stuff's been around for like 40 plus years. I was gonna like sort of say I don't really know anything about what life was like before 2013. So this is sort of like I assume that like all history started like when I entered the workforce. Analytics SQL, which I think is like probably about a decade old by now. Columnar store stuff. The stuff used to be on-prem, now it's in the cloud. Distributed, and then increasingly sort of like what I'm seeing in the space is these streaming databases. The sort of concept of like batch processing versus streaming, I think is increasingly going away. And to kind of start with the takeaways first, like they've evolved a ton. You have to make your architecture decisions in advance, and it's really based around like how you're going to read and write. So really understanding like what's going to happen and how people are accessing is key. And this stuff's like increasingly important basically as you're looking at bigger stuff, you're looking at faster stuff, you're looking at stuff where urgency matters, or you're in charge of your tools and budget, which like I 100% was not even close to being in the room for that stuff at Wayfair, and sort of like increasingly have been, post business school. Cool. So the production SQL database, again, like the Postgres, the MySQL, the stuff's been around forever. It is like the first database you would have at a company. And so for Ramp, like this is what Ramp looks like. When you open one thing in Ramp and it just pulls up your cards, it's going to be this. And so for most kind of canonical like B2C businesses, you're going to have a users database, an items database. All of the data is stored at the row level, because when you want data about someone, you kind of want like all their stuff. So like if I'm looking up me in Ramp, it's like I want to know my cards, I want to know this stuff. So it's like two power production applications. That being said, like for a lot of analytics history, analytics also ran on these style of databases, which were not optimized for kind of like these sort of like long running, million, billion row queries. It's really just optimized for like quick, fast inserts. So this sort of sounds like even like a joke now, but back in the day at Wayfair, if you wanted to run queries on like over 150 million rows, you were just like straight up out of luck. Like you just couldn't do it. And so what that kind of meant is that functionally we had pretty good analytics on what I'd call like the low funnel revenue stuff. Like you could count orders, but in terms of things like website visits, like I think, Wayfair generated something like 160 million rows of data just on a single Cyber Monday in like 2017. So it's like, if you want to add every single website visit together to calculate like an add to cart rate, that was really non-trivial, and you had to do like a lot of clever aggregations and sort of like process chunks of data at a time and sum it all together. Now I think like, I can't even tell you how trivial this stuff is. You just like swipe your credit card, put it in Snowflake, it's getting like cheaper every single year. And so row-oriented databases are kind of like, once you start to have a data team, once you can't run analytics on production SQL anymore, you'd buy a data warehouse, start putting your data in, start putting data from other sources. And this stuff is really, really well optimized for billions of rows of data because it's stored at the column level. But it's going to take like 2 seconds latency minimum. You're definitely not going to build a production site based off of this stuff. And you also can't really answer questions in low latency as the data changes. This is the stuff that I think I'm pretty excited about. I'm seeing like a lot of this coming online. To maybe draw an analogy to kind of like Snowflake versus what was before Snowflake, you could do big data before Snowflake, but it took 3 data engineers to spin it up, 1 data engineer in perpetuity, and it like broke all the time. And Snowflake was really powerful because someone who's a little less technical could just swipe their credit card and like have it working in a day. Streaming databases are there right now, where I think like 2 years ago, it's like you could do it, but you'd probably have to be Netflix or Uber. You have a ton of people setting it up. It breaks all the time. It's just starting to get to the point where you can swipe a credit card and streaming databases just start to work. And so I'll talk a little bit more about sort of this analytical versus operational framework. If you think about kind of like a finance team or a data science team doing research, they don't want the data to move. You're like, I have a data chunk. I kind of want it in a CSV because I'm going to do analysis on it, and I want to, determine a causal effect, or I want to state October revenue. That has been most of my life in data until pretty recently. I think increasingly we're sort of like, what would you do if there are questions that you can ask the answer to once and be notified as the answer to that question changes? So this is kind of that operational workload where you're like, I'm not going to use this stuff just for insights or reporting. I'm going to use it to drive subsequent things that happen. And so I actually think this is a pretty good example of this, which is like an abandoned cart push notification. And actually, I worked at Drizzly. I think this is like a really good example of what it used to be, why that was bad and what it is now. At Drizzly, we calculated abandoned carts every 24 hours and sent out an email. If you're like Wayfair or Lululemon, that actually might be sufficient. You're like, if you're looking for, I don't know, like whatever, a stove or like yoga pants yesterday, you might also be looking for that today. For Drizzly, that's actually kind of insane. you're like, did you want this yesterday at 8 p.m. and you didn't buy it? Like getting that email on Sunday morning is like not what you want to see. It's like the moment's passed. The half-life of that knowledge is extremely short. And so when you sort of think about powering abandoned cart push notifications, you're like, why would I batch that? Why would that need to happen every 24 hours? If you add something to your cart and I add something to my cart a minute later, you should get your push notification a minute before I do. And so this is like a lot more of this stuff is going from kind of the realm of you need to have a massive company with a ton of data engineers to do it. It's kind of like you can spin this up in a weekend with a credit card. Awesome. Maybe I'll pause there before talking about any stuff. Yeah.
Yeah. On that last one. So, where does it roughly where does it break in terms of making the abandoned cart run not 24 hours, but let's say 1 minute? And like, where do you have to make that shift to streaming, the fundamental paradigm shift? Do you have a sense of like what the big difference is there?
Yeah. So kind of going back to right here. I think like a common question is basically something, maybe zooming out a little, right? Like I think I've found if you build something for internal reporting and it works and it has value, people sort of say 2 things to you, which is they're like, I want to operationalize this and I want the answer faster. And so like a ramp example of this is we calculated companies' bank account balances every 24 hours for internal reporting. And that was sort of sufficient until it wasn't. And the exact minute it wasn't was like during the SVB fallout, where we're like, we actually need to know this as things change, because calculating this once every 24 hours is truly like a lifetime right now. The thing about Snowflake is it is sort of like famously one of the highest net revenue retention companies of all time. Like if you pay Snowflake 100K this year, you will pay them 140K next year. Snowflake is not designed to be run every hour. If you run Snowflake every hour versus every 24 hours, you have to be like really, really clever to not 24x your Snowflake costs. So I think it has kind of going back to like some of these questions around like the architecture decisions are really made around latency concerns. You can't really actually load data into Snowflake because it's a batch framework. And I think like, I don't know if anyone kind of remembers how they taught calculus, you're like, you just take littler and littler steps. And eventually it's like, That's actually like the opposite of how data warehouses work, where if it's fundamentally a batch thing, you get in a lot of trouble taking something and running it 24 hours, 1 hour, like 5-minute chunks. So I think for us, we'd sort of like, maybe you have some areas where you run things every 4 hours, but beyond that, you're like, look, is this functionally something you want to do in an event-driven manner? If so, pick event-driven tools.
It sounds like it'll save a lot of cost too.
Yes. Yeah, absolutely. Yeah.
So I used to work at Uber, and I feel like we had a live dashboard of number of trips happening in number of cities. Maybe not exact real time, but it didn't seem that novel that being able to do like crunching a lot of numbers to come up with some aggregate stats on a very high frequency basis like existed 5 years ago. So is this really starting to spread only now?
So I think what I'd say there is like Uber 5 years ago could afford 150 data engineers. And like a lot of the stuff they built was custom. And a lot of the stuff that like makes it into the open source stack, right? Like Tecton is a feature store company. That was based off of Uber's Michelangelo. And like those people were like, we solved this for Uber, the first company in the world that could pay this amount of money to solve this specific problem. We learned that other companies had this need, and we want to be able to solve it for them without the ability to like spin up a 150-person team. So I think I'm sort of saying like, this is probably just getting to the point where like a 20-person data team with like 1.5 analytics or data engineers could spin up streaming stuff in like a weekend. Yeah, but it's definitely like the bigger companies have been able to invest in this stuff for sure for like 10+ years. Cool. Awesome. So yeah, just chat a little bit about some of the stuff I've kind of like worked on. At Wayfair, I worked a lot on their recommendation algorithms and their pricing algorithms. At the time, this was like largely reading sort of cutting edge research papers and then trying to implement them at Wayfair. One of the biggest difference between recommendations at Wayfair and Drizzly is recommendations at Wayfair are kind of hard, where you're like, if someone bought a sofa, they're never going to buy a sofa again. Recommendations at Drizzly were sort of like frustratingly easily, where you're like, 1 week ago, Bud Light. 2 weeks ago, Bud Light. 3 weeks ago, Bud Light. Recommended for you, Bud Light. So that was, I don't know, consumption style industries are easier for recommendations. For Drizzly, like a few things that I worked on. Again, recommendations. Drizzly has a lot of ads on the platform. So that was like a cool project, putting those in. We tried to do uplift style analysis, basically saying if we take people and expose them to kind of like the Diageo suite of products, can we create uplift in their purchasing behavior over time? And what was actually like really cool is Drizzly had sensational inventory feeds because they have to be plugged into all these liquor stores. We actually knew when liquor stores would sell items when we didn't sell them, right? Because you're like, I got the inventory feed a while ago. They had 3 left. Then I got the inventory feed. We have 2 left. I know we didn't sell it, but we actually were able to do some like geo stuff where we said like, can Drizzly actually influence offline purchasing? So that was pretty cool. The ETAs stuff here, I think was probably one of the more complex data science algorithms I worked on. So we don't know where you are in advance. So for a lot of recommendations, you can sort of like pre-cache it the night before for everyone. This stuff you had to do in advance. And I think also like during COVID, when we were getting 10x the amount of orders we're used to, these numbers were like 560 minutes. And we're like, it's like, it's actually kind of accurate. But yeah, I like working on a lot of stuff like this. And then most recently, have been at Ramp. So, unlike Wayfair or Drizzly, where I think it's super obvious what they do, Ramp is a platform for modern finance teams. Largely, I would just sort of say the idea is kind of like, if you've ever used Amex and Expensify or Bill.com and Concur, it is insane that those are all different tools that don't know about each other. I'd say like our original innovation was just sort of like, we should build feature parity in one area. Like the fact that Expensify doesn't know that you've spent money until you tell it you spent money is pretty silly. Like for Ramp, When I swipe my credit card, I get a push notification on my phone because I know about it immediately. I take a photo of it. And to talk a little bit, there's like a fair amount of data and data science stuff going on here. One of the cooler things we do is anytime we get a receipt like this one's actually not that hard because it's like text, but if it had been an image, the first thing we would do is use OCR to extract the text out of the image. The next thing we would do would be to embed that text in a vector embedding database. The thing we do after that is to look at the transactions that we've categorized, do a nearest neighbors lookup with a ton of filtering, because we obviously know, like, I submitted this, it's only going to be sort of like my transactions. You do some element of nearest neighbors matching. You have to wait a little bit because the receipts come in a little bit late. But being able to match receipts in low latency automatically is really nice, because in this instance, we have actually like a Gmail integration. So when I spend money on Amtrak to go to New York once a month, I spend money, it comes into my ramp email, like we're reading my emails, it pulls out this receipt, and it has enough context to sort of say like, the amount of money I spent on Amtrak lines up perfectly. These came in around the same time. They have the same merchants. So that's kind of like one of the cooler data science applications at Ramp.
Yeah, so that, like, it sounds like you were able to add a whole bunch of context to more than just $210. So like, what are some of the things that you're able to kind of bring in to the context here?
Yeah, so it's it's dependent on a lot of things. We had an intern this summer, and they were like, on their last day of work, they're like, I'm too young to know so much about ACH. I think they were like 21. And that's sort of like how I feel about credit card networks. But I think like credit card networks are nuts. It's all still running on like the original protocol from the 1960s, which means they send over so few chunks of data. There's a lot of ways to enrich it. So this is just super random, but like we get more data from Stripe than we get from the processor. We issue cards on Stripe and Marqeta, so we kind of have like two very different flows. And then like another just really weird wrinkle, right, is like, if there's a restaurant near you, you could purchase from it potentially on DoorDash, Uber Eats, from the restaurant directly at their point of sale with your card, or with a card saved to Apple Pay or Android Pay. And all of those are going to give you like slightly different contexts. Like you've probably all seen it on your credit card statement where it's like TST asterisk means like toast restaurant. And if like you order online, that's what it might look like. If you order in person, it's a little different. But largely I would sort of say it's like the receipt, time of day, the merchant processor, and then you might get some more stuff on Stripe, but it's like quite dependent. So it's kind of like, we have to figure out a couple different strategies depending on how much data we get. Yeah. And then there's also like confidence intervals too, where you're like, what's the joy of like matching something without asking for human intervention? What's the cost of being wrong? And like at what confidence interval are we like, we actually can't match this, will you help us? Yeah.
How solved is the OCR step here? I know a lot of the LLMs are now going multimodal. You can put in a picture into GPT. Have you guys experimented with that stuff, or is that just overkill?
Yeah, I will get to that later, because I think that's actually like one of the wild things about LLMs. So I have that at a later slide. Cool. Awesome. So to talk a little bit about the modern data stack, this is kind of like the picture that the vendors would paint for you, which is a good one. And so I think like in 2013, I do think it was sort of safe to say the blast radius of what a data team could mess up was relatively low. It was kind of like messing up a number for a board deck was probably about as big as it can get. What is really cool, I think, about the modern data stack is like, it is extremely turnkey to get data from all of these SaaS tools into your warehouse. And it is extremely turnkey to put it back into these tools. So I think like why this is relevant is most companies have always been able to connect their orders, stores, inventory, items, tables, and like do analytics on them. But back in the day, right, if you wanted to get data out of LinkedIn ads and out of Zendesk, that was actually pretty tough. Like you had to have someone build it for you. And that's like not really that strategic, right? It's like a lot of companies need their Zendesk data, a lot of companies need their LinkedIn data. And if you can't put all of those things in one place, you cannot unearth insights that are only relevant with both of those data sets, which, for example, are like if people who come in via LinkedIn ads incur massive support costs and generate more tickets in Zendesk, you can't do that if all of your data is siloed. So that's been like really cool. Is it's like you can generate more cross-functional insights really quickly. And when someone says, we're using a new tool, you can usually get the data into your warehouse within 48 hours. Moving it out is also pretty powerful, which is to sort of say like, to the same extent that, you know, the blast radius of what you could break was pretty contained 10 years ago. Like, I think the career of a data professional was sort of constrained. We were like, all I can do is internal reporting. And now, like, you can put data back into Salesforce, you can drive operational workflows. A data team can be responsible for sending abandoned push notifications. A data team can break those things. One thing that I broke is I got a time diff messed up. Drizzly had something where we did push notifications if it was gonna like rain or snow, so you do your order in advance. And I think I staggered it like 4 hours too early instead of 4 hours too late or something like that. So like everyone on Drizzly in Boston got a push notification at like 3 a.m. telling them to buy alcohol. And that's like a new thing that we could break, which is sort of like exciting because you obviously have more scale. So anyway, this is kind of like what it looks like, which is to sort of say, yeah, go ahead.
Yeah, is this the stack that Ramp uses? And if so, or if not, are there any tools that I guess are easy to rip out or aren't super useful to you?
Yeah, so this is kind of like a choose your adventure. So I'd say like many people have production SQL. This is Postgres or MySQL. You could kind of pick one or the other. In this extract load area, it's like Fivetran and Stitch. There's a couple more. You'd probably pick one of these tools. You'd probably pick Snowflake, GCP, or Redshift right here. Almost everyone uses dbt in this transform layer. That's high touch and census. You could pick either of them. We use high touch. My previous company used census. You pick a BI tool, and then like, so I'd say kind of all of these are like categories and chunks with sort of more than one winner right now.
Except Salesforce, which is its own name.
Yeah. Yeah. But this is sort of like what the modern data stack looks like actually, which is to sort of say like the red's not coming through very well in these slides. There are about 6 places where you can look up total website visits, just because there's a lot more sources of truth and they're federated out. These tools all read and write to each other quite a bit. So I think like it's all a very good thing, but you just have to be extremely structured about what writes to which tools and why, because it's so easy to build connectors. And I think, frankly, it's so easy to build kind of like low code, no code UI connectors, where someone that you're like not aware of has started writing to Salesforce from a custom API based on something that someone does on the website. And so it's really hard to kind of detangle what the permissions look like for these things. So I think you're going to see basically a fair amount of, if not consolidation, like engineers have had to solve problems like this for a while with like microservices and encapsulation and like who has API permissions to write to what. The modern data stack like really lets you go nuts here without a lot of controls. And like you can get stuff up and running in 48 hours, which is pretty cool. But it can be really, really hard to unwind. And like there's a phrase that I like, it's called like SaaS debt, where you just end up in like a lot of SaaS debt pretty quickly. Cool. So here are loosely some of our data sources for Ramp. And you can sort of see they're categorized as like driving people to Ramp, closing people in the enterprise sales cycle, the actual Ramp product. So we have a ton of Ramp data. Segment is kind of what we use for event instrumentation. You can use like Amplitude, you can use a couple other tools there. Datadog, LogRocket, and then kind of all the tools that are a little bit more downstream. So for example, like Plaid, Zendesk, QuickBooks, Oracle, NetSuite, Rudder, Marqeta, all these things that we use to kind of know what's in someone's bank account. Are we moving money correctly? Are we syncing things back to their books? Cool. Awesome. So yeah, I already showed you a little bit of a slide like this, but I think this is really kind of the 2013, 2021, 2023 plus, which is like at Wayfair back in the day, if you had data in 2 places, which you often did, you were kind of out of luck. because you had these on-prem SQL servers and you couldn't just scale them easily horizontally. You're like, this is as big as it gets. So this is like our orders data, our tax data is over there, our product analytics data is over there. 2021, I think it was really, really easy to combine all this stuff in Snowflake. And you start to have that ability to, when a business has a large drop in bank accounts or goes delinquent, not only do you have that for internal reporting, you can write it to Salesforce and Zendesk pretty quickly so people have that context. And now this is sort of like what I was saying, where this is something that a data stakeholder increasingly can say at an increasingly small company, where like someone who's not extremely technical can spin it up, in a weekend. Just like, this is great. I want it faster. I want to operationalize it. And I want this to be sort of like known and spread throughout all of our tools. Cool. Awesome. And then I wanted to show basically the LLM application at Ramp that I'm closest to, and then talk a little bit about kind of like some more generalizations. These are Looker contracts. I have purchased Looker 2 times and renewed it 5 times. I have no idea like what Looker costs and why. It is just an absolute price discriminatory crapshoot. And so Ramp, kind of by virtue of our scale now, has, we don't have 1,000 Looker contracts. We do have 1,000 Salesforce contracts. And so to start answering the question like a year ago, what does Salesforce cost? We just got 4 people in a room and we just read 150 contracts by hand. And we just started to like, so for Looker, this is kind of what a schema for Looker would look like a JSON schema for Looker that represents the same information on this PDF. As it turns out, as you all probably know, like this is something large language models are incredible at. And so you can take that, like you can't load this into Snowflake. You can definitely load that into Snowflake. And then you can run averages and means and just like super standard mathematical stuff on top of it. And so I think kind of like from a general LLM thought perspective, I think it's sort of underrated to think about how can you take text and extract structure from it? How can you write PDFs to something that's machine readable, like a JSON blob? How can you summarize big to small? I think sort of famously, everyone's like, GPT's awesome. You can give it like 3 bullet points and it'll expand it. I think like the contraction is a lot cooler. I think sort of the small to big, at least in a business setting. I don't know, I just haven't seen as many awesome, super relevant applications to me as I have from sort of like, take a PDF, turn it into JSON, read the JSON, run sums and means and like super standard stuff on it. I think it also has some sort of interesting implications, which is like, the last layer of this is the simplest, which is like a really easy query in Excel for SQL. So like what's going on in this JSON stuff. The large language model component is a lot earlier. And so going back to that OCR question, this is something that I think like has definitely messed with me and like changed my mind a lot in the last year. Everything I know about data science is that the domain knowledge is super important. Like the generalizable companies, I don't know, there's like a lot of these companies from probably 5 years ago that are like, just send us your data, we'll kind of come up with an optimal model. And I think like in those situations, often you're like, the business domain knowledge and understanding the cost and data generation costs are so important. I think here, and this is like far from I'm far from the first person to observe this, but like, we worked with Scale.ai on a receipts API. They literally just have a team of people thinking about how does Scale sell receipt matching? And we found that GPT-4, just generalized, did better on receipt matching than this thing that Scale has worked on really hard, getting receipt data, labeling it. It's just trained on receipts. So I think that's just sort of wild, is that like, this is the first time that I've been in the data space that these sort of more generalized models perform better than really specific models trained on that exact task, which I think is pretty wild. I think this also has some, oh, sorry, go ahead.
Okay, my bad for interrupting
Yeah.
again, but why do you think that is?
That's a good question. I think largely it has to start to get into kind of the realm of like what is encoded in these parameters and what is in the data set. I think something that I've heard in the past is that like if you take an autonomous vehicle like a Tesla, you train it for like hours and hours of driving, and then all of a sudden you're sort of like just on a road and a beach ball is on the road. You're like, you're a human being. You're like, that is under half a pound of plastic. I'm not going to swerve off of the road. I'm not going to hit the brakes. I'm just going to run over this beach ball. But if it's a bowling ball, you're like, I'm going to swerve, I'm going to hit the brakes because this is going to like ruin my car, like damage it. And no aspect of Tesla's prior knowledge has been trained on that. And it's like your experience at bowling alleys and like, I don't know, whatever settings you like encounter beach balls in is like relevant to how you make that decision like that. And that is, I think, sort of like the loosest hand waviest, how many parameters, how much text it was trained on answer I have to why I think like training on more things, I think just makes it like a little bit more resilient at anticipating things outside of the tighter data set. But I think that's obviously something where like, I think there's probably only like 15 people that could really give you an eloquent answer to that. And I'm sure it'll be different like 6 months from now. Yeah.
Are you seeing so GPT-4 does a better job on matching performance, but is it like cost wise or like latency wise, is it still worth it for you guys to use a more specific thing like the scale yacht model?
Yeah, so this is another one where I think like the answer is going to change 30 seconds from now. We paid a lot of attention to this stuff, and I think like even within the realm of OpenAI, we paid attention to GPT-3, GPT-5, 3.5 Turbo, GPT-4, GPT-4 Turbo, I think just came out. And they're sort of like, seems like every 6 months, it's sort of coming down by about 75%. So you definitely test this stuff, right? Because when someone uploads a receipt, the math, I think probably 6 months ago was like somewhere between 3 cents and 12 cents. And you're like, that's actually pretty substantial when you're a credit card company, like making tiny amounts of money per transaction. So it is definitely something you think about, right? Like, again, a lot of people have written about this. When you think about most data science through the years, training the model was expensive and inference was comically cheap, like fractions and fractions and fractions of a cent. And so it kind of meant that you could have these data science companies get spun up and they could go for a really long time without coming up with a plan for revenue. But all these LLM companies, the cost to serve is like actual cents per inference call, if not more. And so it's just sort of fascinating because I think really they charge you faster because they have to have a revenue plan faster, which I just think is sort of fascinating relative to kind of like a lot of the past startups is you can't really go a year serving millions and millions and millions of API calls, each of which costs you like a couple of cents, not have a revenue plan. So I'd say we definitely pay attention to it, pay attention to like self-hosted versus AI, and it's all changing so fast, you have to pay attention to it.
On the general models, be domain specific, do you think it's very dependent on a few use cases maybe? And this one, the reason I'm asking is because I actually haven't heard this very much. And I've heard, and maybe like, and I don't know if this is like, if you're seeing this 10% of the time and you think it's gonna grow and that it's just, things are changing so fast in this space and it's fine, or if you think it's like you're hearing this 50, 60, 80, 70% of the time or whatever, like how often are you hearing this?
So again, I think it totally depends and the answer changes really fast. I think the individual paper that I can kind of like remember the most on this that I think is pretty relevant is if you think about fine tuning models, usually what that means is you get a ton of parameters, you take your own data, you fix all of the layers except for like the last 2 or 3 layers, and you run a ton of backprop. So it's like the actual models and weights have changed as a result of your fine tuning. And I think up until probably 6 months ago, people were like, that's how to tailor stuff to your use case. It's like you take your data, a pre-trained model, and you fine tune it. And then the models got 10x bigger. The context windows got 10x bigger of like what you can feed into the model. And then I think a lot of the conversation went from like 0-shot prompting to few-shot prompting. And so an example of that is 0-shot prompting is you get a customer service ticket and you say, please categorize this customer service ticket. Few-shot prompting is every single prompt you send says, here's a ticket, here's how I classified it. Here's a ticket, here's how I classified it. Here's how the ticket, here's how I classified it. So every time you're inputting context, like you're sort of putting context in, and then the very last thing you say is you're like, given everything you just saw in this context window, please classify this ticket. And I think what people are seeing is that the bigger general models that you have not hand-tuned with prompts and few-shot prompting that you've like hand-tuned extensively performs better than trained models. But I think to your point, like general models beat domain-specific models. I think it's like, obviously to your point, entirely dependent on like which domain it is. And I think a lot of what OpenAI does generalizes pretty well to like receipt matching, but it might not for something totally different.
I mean, even thinking like the verticals of summarization or Q&A or I bet it's also dependent on those things. I think I could see your examples fit that really well. Then I can see others where maybe less so. So that's just an interesting point.
And I'm sure they'll all be different at the end of this talk. I'm sure. Yeah.
So fast moving.
Yeah.
Just to understand the receipts example you gave, were you trying to find how much Ramp was paying for Looker or how much Ramp's customers were paying for Looker on average?
So a little bit of both. And I think our vision, right, and I'll give you something that like definitely happens to CFOs, is they say, hey, tough times, we got to cut our SaaS spend by 25%. And we would like, we're not there yet, I think we're actually pretty close. It's like if you have 80 SaaS tools, we want to be able to tell you which 20 of them you have a bad deal on and which 4 of those are coming up for renewal soon. We actually also like to tell you which don't discount. Slack and Figma don't discount. Every single person on Ramp pays the same for Slack and Figma. That's actually really powerful if you're a CFO, because you're like, I'm not going to get my 25% here. I'm going to save myself a lot of time and go somewhere else. So that's the vision, is that basically, you know, these extremely opaque deals, you can start to kind of like price in a way that makes people pretty confident that they're getting a good deal. Awesome. So I think this one's also like, I don't know, y'all might have heard like a fair amount about data science interviews. Like you get a lot of questions on ordinary least squares, which is sort of like the workhorse of statistical models. I think they really test pretty aggressively that you never want to put anything into production that you couldn't, if not like whiteboard on the fly, like understand pretty intimately. The people that I have seen have the most success implementing large language models in production settings are those who just absolutely like hack at it. And I would call it like just-in-time learning in the best way, where they're like, I am going to learn the absolute bare minimum about this tool necessary to implement what I'm trying to implement. We have seen like product managers for our internal tools team. We've seen like one pretty scrappy account manager build stuff on this. And so I think unquestionably, if you are interviewing someone to build large language model tools at your company, it would be pretty ridiculous to have them represent like what a bidirectional representative transformer is or whatever. Like that would be a ridiculous whiteboard interview. And I think this is like a bit of a pivot, because I think when people were doing convolutional neural nets, which is sort of like, I don't know, the cutting edge before the transformers, you actually would have whiteboard interviews where you're like, please show me that if you needed to, you could build this in Python by yourself. And you could go all the way down to that layer of abstraction. But now I think these tools are very much sort of like API abstractions, where maybe if you're at like a top 20 tech company in the world, you need to be able to build it from scratch. But for the most part, you're like, let's just imagine these tools exist and are getting better all the time. Let's build as fast as we possibly can on top of them. We don't necessarily need to gatekeep. Like, does this person know partial differentials on this stuff? Cool. Ultimately, I think it's proprietary data. I think everyone knows that, but it's like the algorithms are going to come and go. The papers are out there. The data is the stuff that's valuable. Process consistency versus output consistency. This is, I think, the thing that's still like when you talk to these tools and you like chat with them, it can definitely feel a little bit alive. This is, I think, my favorite example. So this first, someone asked one of these tools a while ago to translate something from English to Portuguese, and it said, you know, a médico está aqui, which is masculine. And then they said like the teacher is here, and it said the professor is here. And then for the first one, they're like, why did you translate it that way? It's like nouns have grammatical gender, the default form's masculine. And then when you say the professor, it says like the sentence did not specify the gender of the teacher. And so imagine these are like two different, you know, Chrome windows that asks one question, asks the other one. And so I think the critical thing here, right, is that like, you would think that when you say, why did you say that? It's telling you how it reasoned. It's not telling you how it reasoned. It's predicting the most logical next token based on what's already said. What it has already said is that this noun ends in an O. So it will tell you the reason it got there. It'll come up with a reason that like makes sense for how it ended up with an O. And if you have it have a sentence that ends with an A, it will tell you like a different reason, one that makes sense for how it arrived at that place. So I think just like being super clear, and I'm not paying attention to any of like the new like Q star OpenAI stuff. I think that kind of gets at a lot of these problems, but just calling out that like functionally all this thing does is predict the next most likely token. It's not telling you how it works under the hood. It's just telling you when you read something on the internet and someone says, why did you put an A or an O at the end of it? It will tell you the thing that's most likely to occur after it, not having realized that like it wrote an A or an O earlier in its process. Cool. Any questions on any of this stuff? Awesome. I had some unsolicited data career advice for MBAs, but you want to go back to this one? Yeah.
Yes, one question. I think a lot of us took a DSM course the RC year, and you can just throw in the data into ChatGPT. It can run some basic analysis for you. So I'm curious, among data analysts and non-technical people, are you seeing them using ChatGPT in production to query data?
We're really trying to make it easier. And I think what I'd say is like every Salesforce instance I've ever seen has like like final V2, final H1 V2. And I think the settings that I've seen research papers about can large language models generate SQL well, it's sort of like, yes, it can, but, and it's like, there are 13 tables, all are named perfectly, and there's like an ERD that connects it perfectly, which is sort of the equivalent of being like, if you show up to work on your first day and there's absolutely perfect documentation and no legacy tables and no legacy columns, like it's actually pretty easy to do your job. And so I'd say like that's the piece we're trying to get around is like, how can we provide these enough context? And I think like the current phrase people are using is knowledge graph, which is like, if you have 3,000 tables, you have 10,000 total columns, it's not going to do that well. If you can come up with like some sort of representation of a knowledge graph of how it all fits together, I think that's sort of the cutting edge. We're not there yet. I do think it'll be interesting to see like, does a startup get there first or does Snowflake get there first? Because they have all this legacy data about which columns and metadata people are looking at. I would probably bet on them doing it, not because I think they have like the best engineers, but just because I think they have like sort of proprietary access to how people are actually looking at data. Cool. Awesome. So here's my unsolicited data career advice. This one I think like definitely relevant for MBAs who might be going to something more technical. You can just always read the docs. Like all the stuff, the docs are available. It's like an extremely open environment. No one will ever tell you to read the docs, but you can always do it. I think like the stuff I would not overstate kind of like how quickly you can become an expert at it. Yeah, you can learn a lot in 2 weeks. You can learn a lot like in a single weekend. I tell my team this a lot. There's a lot of people who are like, I can do data science, but I've never built a data science service. I'm like, so many people on YouTube. Just like watch it on YouTube, learn what Docker is, like build an API, swipe your credit card for $5 to get like some AWS tier. Like you could put this, you can do this in a weekend. And it's like so differentiates you on a resume or in a job interview. this one, I think like if you can be in a spot at a company where you understand the narrative that your leaders care about, and you can find the data to back it up better than anyone, it's like a really, really good and dangerous place to be at a company. You can kind of like have a superpower if like, the CEO's, no one knows the CEO's narrative better than you, and no one can pull data better than you. Like, you can go pretty far. This one's obvious, and I think not really data specific, but I think like selling your vision, just like super important, having your work adopted. There are data science models littering the floors of corporate America that like someone built a data science model and no one wanted it. I think it's like, especially for marketing, if you're like, I actually don't think that TV spend was effective, like people don't always want to hear that. So you have to find projects that people want to work on. And this one, this is a hill climbing algorithm over here on the right. And sort of the key tenets of a hill climbing algorithm are you always want to optimize for steepness. This is kind of like calculus, right? You're like, find the steepest slope. I want to climb that. If you're at the top, if you're somewhere flat, make a jump, find somewhere else to go. And then this one, like the younger you are, fewer hills you've climbed. This is like exactly how hill climbing algorithms work. So like, how much time do I have left? Where's the steepest? I'm at the steepest. Let me go somewhere else. Awesome. That was all I had. Thanks, everyone. Yeah, happy to answer questions here.
Thanks for coming. So my name's Eric. I've got a question just about your experience at Ramp over the last 2 years. I know that the company has gone through like pretty rocket ship growth, at least definitely in 2021. I don't know about in the last year or so in terms of headcount, but what did that look like? Like I imagine your org has grown a ton, like processes have probably grown a ton too. Like what's that transition been like? I don't actually know how much bigger the company got in those 2 years, but I imagine it's like an order of magnitude or something. So yeah, can you speak about that?
Yeah, so I think, if you get me like 5 years from now, I'll probably be like, I was the reason it all happened. It was already so successful before I was there. It was like already the fastest growing company to B2B company to $100 billion in revenue. I think Deal has subsequently replaced us. But I think like compared to Drizzly and Wayfair, those were companies that had really hard business models where everything overlapped and intersected. Where like, if you dropped your prices, you would sell more. If you sold more, you would have more customer service tickets. You would have like more operations. You'd have last mile logistics. One of the best parts about Ramp is, I think it's not like no one really steps on each other's toes. We have an accounting team who's like just heads down on making a better accounting product. If they do that, it won't lead to kind of any negative effects. So I think we're extremely siloed in the best of ways, where people come in and they're like, you're going to focus on this thing. You're only going to focus on this thing. You're just going to ship on this thing. It doesn't like take the 3 most important things you have to do, cross out the bottom 2, and we're going to ask you like why you're not doing the top 1 faster. And I think as we've grown, we've tried to keep a lot of that, which is to sort of say like, let's keep those small cross-functional product engineering data design pods, hire 6 people, put them on one really tough problem, and like tell them to like tap us on the shoulder when they're done with it. So we've definitely tried to do a lot of that. I'd say probably the challenges are mostly going up market a little bit, which is sort of like just a really different sales cycle. Like Shopify is our biggest customer. Obviously, if they like tap us on the shoulder, we like listen to them and figure out what they need. But I'd say largely it's like we've tried to keep the culture as similar as possible, which is like those small cross-functional groups working on one problem. Yeah.
What advice would you have for us on picking the right startup to work at? So given you've worked at 3 different places, I'm sure you would agree that sometimes the success of a startup can feel somewhat random. It seemed like Drizzly really benefit from COVID. So given how much randomness and luck is involved, how did you think about picking the right bet to place?
Yeah, so obviously, right? Like, I didn't know COVID was going to happen in 2019. But I think like, I'd say there's probably a few things, and some of this is just so like revisionist history. But I think one is like, if you can tell yourself a story as to why this company is going to grow. And also, I do think that like at any of our career stages, you have to also ask yourself, like, what department is gonna grow? Like, are they gonna want to invest in this department? I think that's like some of the best advice I got is like, go someplace they want to invest in you. I was gonna say something else, I totally forgot though. Yeah, if you have the opportunity to like move really cheap alcohol or move money on the internet, I would probably move money on the internet. Yeah. Yeah, I think maybe last piece would sort of be like, I have not gotten a job that was available through like a listing since I was 21. And so I think like the smaller the company, the more you can kind of create a role for yourself. Sometimes that's taking like intros and intros and intros until it sort of turns out they're interviewing you. Sometimes it's like talking to someone and being like, this is what I want to do. Can you make this role happen for me? But I'd say that's probably the number one advice is like, figure out how to create a role for yourself. Because obviously like everyone knows this, but it's like, if you're in a stack of 600 resumes, one, it's like hard to get out of that stack. And two, it's like hard to be compared again on like on your own merits against like how that stack is calibrated. Like if you're like, actually, I think I'm like senior manager. They're like, well, there's like 600 resumes here. So like you're manager. So yeah, I'd say like figuring out sort of side doors and like really making your own narrative and like selling yourself is probably important. Yeah.
Kind of building on that startup question. When you were reaching out to people and figuring out your way in and like you're on a call with them and you're saying, I don't want anything, I'm just a student looking for information, the typical thing. How do you at the end get to the next one? Like, are you just like, is there anyone else you can think of who might be worthwhile talking to? What did you find successful when you were doing those things? Especially if they were like, no, not right now. I'll see if I can think of someone, which is like death.
Yeah. So I think this is probably a little bit more relevant to any of you first years. Yeah, so I did an independent project, which led to my first job at a business school. And it was on data science leadership. And I was sort of like, I've been a data scientist, went to HBS to like, obviously learn more about like management and leadership and finance. And I kind of reverse engineered it to talk to like everyone whose job I wanted or everyone who could hire me to do the job I wanted. I ended up probably having like 30 conversations with I think like 16 or 17 companies. You all probably see this like a fair amount for VC roles because like everyone wanted to break into like VC PE. And so I was like, oh, I'll just take that and do it for data science because like it doesn't seem like anyone's really doing this. So I know that's sort of a specific one, but I think like that was the case at the time. And then I'd say after you're done with school, figuring out how to be known as someone who can solve a problem that a company is having is probably like how I got the ramp job, which is one of my friends was like, hey, our CTO is hiring someone for data. I don't think he knows what he wants. We don't know what we want. Like, will you talk to him and just like, here are the problems we have. And like, you can give him advice on who they're like hiring. And I'm like, okay, here's what I think about. Here's what I test. If you want me to like read the job description, I can like make any edits. I was like, oh, like I wouldn't do that. Like I wouldn't hire a data scientist. I'd hire a data engineer. If your data's like not even in there, you don't want to hire like a data scientist. They're not gonna be able to do anything. Like hire a data engineer, have them move the stuff in. And then he's like, would you be interested in this hiring? And I was like, no, like probably looking for something more senior. He's like, okay, what role would you want? And I was like, I want to lead your data team. He's like, okay. And it was like, honestly, really embarrassing how little they interviewed me after that point. But yeah, I think like getting known as a person who this is probably more after graduation, but like if a company is like, oh, you should talk to that person to answer the specific problem you have, and if that can lead to being like the person who solves that problem for that company, I feel like you can kind of figure out your own like leveling and seniority a lot easier if it's already been established that they're talking to you to solve the problem they have.
Should we just take the last one and then break and folks can meet you and perfect person? Yeah.
Oh yeah, like I kind of on a similar vein. I love what you said about like there's just so much you can learn in a week, just doing on your own. It sounds like there's been a lot of benefits, obviously, to the MBA. Kind of a two-pronged question is like do you feel like going to MBA was like the absolutely right decision for you? And then also like, you could have also built while you were here, for example. What made you decide rather than building something on your own, you would kind of more be rather join, for example?
Yeah, so I'll probably answer the second one first, which is, I had some people in my section who really wanted to be founders, and I think like at least two of them have been pretty successful. I think like one of her first ideas, I think we're all like, it's like pretty dumb. And she like ran at absolute full speed, pivoted once or twice, and now like has a pretty successful company. And I think like for her, really wanting to be a founder is something I just didn't really have during business school. I definitely like still don't think I have that right this second. I think the other thing, this is sort of true and challenging about data, is like you never hire a data person as your first hire. So you're like, we don't have any data, we don't have any sales. You're like, I need a product person, a designer, and an engineer. And a data person, unless you are founding a company with data at its core, like maybe like ZoomInfo, Clearbit, like Axiom, like you scrape a whole bunch of data and then like figure out how to sell it. You're not going to hire a data person. So I think for me, it just wasn't something I was thinking about. I don't know. I feel like if I did it, it would be kind of in that like Uber Michelangelo way, where I'm like, I have solved something. I know the market size. I can generalize this and sell it more. In terms of like, was an MBA helpful? I think for me, the first time I really felt it was helpful was during Drizzly's Series C fundraise. And again, this is kind of going back to like, the CEO's narrative better than anyone. I think like every single person in this room, I bet, was like pretty good at knowing what their manager wanted before business school. I'm like, you're like, I'm gonna manage up, do what my manager wants. I was like that too. I think like being able to sort of see a couple levels beyond that, I think I really needed business school for that. The CEO's like, hey, will you pull this for the data room? I'm like, well, like we're doing a Series C fundraise. What does a Series C investor care about? Well, they want to put in money at this amount and like get it out somewhere between 5 and 12 years later, at like this amount. The exit will probably at that point be acquisition or public markets. Public markets seem to be valuing companies based on like GMV and contribution profit. That's kind of like the benchmark multiples. So if they're putting in money here, like you're doing IRR in your head, you're like, you need to pick data points that paint a picture of X, Y, and Z. And I think for a company like Drizzly, it was sort of like, okay, based on all of that, we really need to convince our Series C investors that the right way to think about our business is by looking at markets on a cohorted basis, which is to sort of say like, you have to believe that you can like turn a flywheel like Uber can. You can't just look at like all of the US and say, like, it's not growing that fast. You have to like pick the areas that it is working and sort of like take a bet that the markets that are working can be replicated. And I think like having those conversations, like our VP of engineering or VP of product, it's just like, I not to be like mean to them, but it's just like they hadn't gone to business school. I don't think that stuff was going through their heads. And I think that was kind of an area where like I got to be in a lot more rooms because I could kind of interface between like the data pull and like the questions the investors were asking. And I guess like our CEO kind of like knew I wouldn't like shoot myself in the foot because I knew the narrative that he wanted to explain to our investors. And I met my wife.
Ian,
And I met my wife in business school. So.
Oh,
Yeah.
The best part of all.
Yeah.
Ian, one from Zoom. I think this is a question around just the landscape, particularly of Ramp. And when you think about the view between Brex and Ramp, I guess Brex had a valuation go down by 67% or something since the last fundraise. And I think the question is just around how do you see this landscape evolving, and do you see like winner take all, winner take most, or do you think, how do you see them prevailing or not prevailing, or what that might look like?
Yeah, so I mean, I think like the reality is we're small, Brex is small, Airbase is small, Divvy is small, Chase and Amex are absolutely massive. It's like 70% of US corporate spend, I think, is still on Chase and Amex. I think we're all under 1%. So like not to be like flippant, but it's like we don't really think about Brex. And I don't think Brex thinks that much about Ramp. I think all of us are like, we have to execute on a product roadmap for the next 10 years. And like, we're definitely not really paying attention to sort of like quarterly anything. It's much more about like, what is the product vision?
Cool. Well, thanks so much for a great talk. If folks want to get in touch with you, is there a good place for them to do so?
Yes, I'm Macomber at ramp.com or actually I'll give you my personal. I can just put it up right here, but it's like Ian Macomber
At Gmail.
at
Okay.
gmail.com.
Gmail.com.
Oops. Gmail.
I'll get it.
Cool. Thanks.
Yeah.
Yeah. Awesome. Thanks.
Thanks, everyone.